Hello everyone. Today we are going to discuss how to perform these IoT projects with Node MCU board and the Blink application. So for all the IoT projects which we have listed here, we are going to use four steps. The first step is making the circuit connection. Second stage is to create a web dashboard on a Blink IoT platform. Third stage is to create an app interface in a Blink application in mobile phone. The fourth stage is to write an code in Arduino IDE software, and then we are going to test the project. So let's get started and see how you can create this project. So for example, we have used this controlling one LED on and off project. Let's see how you can experiment this project. So as I said, first of all, you have to create a circuit connection for this project. So let's see what are the components required for this project. So as usual, we will need one smartphone for a user interface. Then we need a Blink app, the cloud interface. Then we need a 9-volt battery, an IC7805, jumper wires, breadboard, LED, 220 ohm resistor, Node MCU board. So this is the flowchart of how the process is going to work. So we are going to control the devices with the help of our smartphone. So whenever you will give the signals or press the buttons from the smartphone, it is going to transfer the data to the Blink cloud. The Blink cloud is going to control the Node MCU board, and then the Node MCU board is going to control the output device, which is LED in this particular project. Now this is a circuit connection for controlling one LED on and off. So as you can see, we have connected a positive terminal of battery to the input pin of IC7805. Then the negative terminal of battery is connected to the ground pin of 7805 and to the ground pin of Node MCU board. The output of 7805 IC is connected to the VIN pin of the Node MCU board. Then the LED connections are there. So the positive terminal of LED is connected to the D4 pin of Node MCU board, and the negative terminal of LED is connected to a ground pin through 220 ohm resistor. So these are the circuit connection. Now let's see how can we set up a web dashboard. So open a Blink IoT platform in your laptop or a computer. Then click on this developer zone. Then click on my templates, and here click on new template. Then write the name of your template here. Select the hardware as ESP8266 and select the connection type as Wi-Fi, and then click on done. Then you will get the template ID and the template name. We are going to use this in your code. Now we have to create a data stream. So click on the data stream, click on new data stream and select a virtual pin. Then enter the name of the pin, give the pin number as V0, then select the data type as integer and then click on create. Your data stream will get created. Now we have to create a web dashboard. So click on web dashboard and drag and drop one switch widget to the screen. Now go to the setting of this switch and select the data stream here and then click on save. Now we have to add the device. So click on devices, click on new device, then select from template and then choose the template which we have just created and then click on create. So your device will get created. Now we will get a template ID, a device name and the authentication token. We are going to use these things in our code. Now for mobile interface, we need to install a Blink IoT app. So open the Google Play Store or App Store and then install this Blink IoT application in your device. Once you open the application, you have to log in with the same email with which you have registered on a Blink IoT platform. Once you logged in, you can see the application created on your screen. So select the template and then click on the widget icon on the upper right corner here. Now click on the plus icon on the right and add a button widget to the screen. Now go to the button widget setting, enter the title in the design tab, select the data stream, the mode will be switch and then exit. After setting up the button, click on exit. Now this is the code for controlling the LED on and off. So here we have defined Blink template ID and Blink template name, which we will get from the Blink Cloud. This is used to link your code with the Blink Cloud template. Then we have written hashtag define Blink print serial. This line will allow the debug information to be printed on the serial monitor. Then we have included the library of ESP8266 Wi-Fi. It will enable the Wi-Fi functionality on the Node MCU board. Then we have included the library of Blink Simple ESP8266. This will communicate with the Blink Cloud. It will enable the ESP8266 to communicate with the Blink Cloud. Then we have defined the Blink authentication token, which we will get from the Blink Cloud. It is required to connect your device to the Blink account. Then we have created 3 arrays for authentication token, SSID and the password. Here the authentication token we will get it from the Blink Cloud, and SSID and password are the credential of our Wi-Fi network. Then BlinkWrite V0 is a function that triggers whenever a virtual pin V0 changes in the Blink app. Here the param.asInt, it will get the value which is sent from the Blink app, either 0 or 1, and it will send it on a D4 pin. So it is going to turn the LED on or off depend upon the changes on the Blink app. Then in the setup function we have defined the D4 pin as output. The blink.begin command is used to connect the Node MCU to the Blink server. Here we have passed some parameters: authentication token, SSID and password, then the name of the server, that is Blink Cloud, and AT is nothing but a port of communication. Then in the loop we have written blink.run. It will maintain a connection between the Blink server and keep receiving the app commands. Once the code is done, click on the upload button and wait till the code is getting uploaded in your board. Once the code is uploaded, it will automatically get connected to the specified Wi-Fi network. Now open your mobile application, click on the switch, so it will turn the LED on. When you tap the switch again, it will turn off the LED. So this is how you can control the LED on and off with the help of a mobile application. So these 4 steps you have to follow for all the IoT projects. The first step is creating the circuit connections. Second step is creating a Blink Cloud interface. Third stage is creating a mobile app interface, and the last stage is the Arduino IDE code. We are going to given all these descriptions and all this documentation in the description link below. So you can get the things from there and you can experiment all the projects. Thank you.